Hi everyone, in this quick video I'm going to show you how to perform memory forensic for the Ethereum or EVM smart contracts and how to basically extract credential and sensitive information from basically deploy the smart contract on the blockchain. So let's do it. To represent the concept here, I've tried to make a minimalistic contract. I would call this contract accounts or any other given name, doesn't matter really. This is a minimalistic Solidity contract to just represent the context here and the idea, the concept here. And later on we are going to perform our forensic on a already deployed and vulnerable smart contract. So when we are talking about smart contract, as I mentioned earlier, this is a stack-based machine and it has its own basically memory space. So if you're familiar with normal programming, you can see memory spaces like arrays, something like that. And the first, for example, index here would be 0. So when we define a local state variable, the first local state variable would be index 0. So let me define something for you guys. I would say, uint public pin code, and let's assume that pin code is visible to everybody and people need to pass the password in order to authenticate to this system, just as imaginary scenario. So pin code would be something like 9878, and then we have another local state variable. I would call this uint public account ID. I can actually put this even before this. The type gonna be variable public and account ID. So imagine the ID is some random number like that, and here is the pin code, and we do have like a password, and the password is a sensitive information. So people can see the pin code and account ID, but they can't see the password. So the password would be something like bytes, bytes 32, key or password or whatever you want to call that. So newbie, or I don't know, a wide range of developers might make a mistake and think that because something is defined with a private modifier, this is not going to be visible for the outside world. But in this case it would be, and we are going to exploit that. So we call this password, and that's going to be something like A, B, B, C, C, something like this. All right, so here imagine we have, I don't know, a bunch of functions and authentications and so many other things. Okay, so we don't really we don't care about the rest of the code. So what matters for us is the concept here. So as I mentioned earlier, you can imagine that the EVM actually manage these local state variables like memory or array slots. So each basically uint or each slot of memory in the EVM takes exactly 32 bytes. Okay. So that being said, we have uint which is uint 256. That means it takes 32 bytes completely. So that's gonna be located on slot 0. The other one is another uint, and it takes also 32 bytes. That means the next slot of the memory is gonna be slot 1. And here we have bytes 32, which takes 32 bytes. So it's gonna be a slot 2. I mean, real world scenarios, of course, smart contracts are way more complicated and they might have more, types and things like that, but we just try to make it very simple. So how we can hack this contract? The bug here, as I mentioned, is here. Many developers think because the modifier here is private, this password is not visible, or it is invisible to the outside world. So people can't see that, and only a legitimate user can access and enter the password and authenticate to the contract to do some operation. That's wrong. Whatever you do inside of a smart contract is visible to everybody. And so I'm going to show you how we can take advantage of this bug for a already deployed contract. All right, folks. So the basically vulnerable contract has been deployed on Robston, and here is the address of that. So if you go to Robston and search for this contract, we can find it online. So we know this is buggy, so we are going to practice, on this one. So how we can practice? You just need to go to your console. You need to install Truffle. Truffle provides you a whole bunch of APIs for deployment, Web3 APIs. You can do a lot of different things. All right, to do so, as I mentioned, I'm gonna use Truffle. So I have already configured my Truffle to work with Robston. So to do so, the first command is gonna be Truffle console network Robston. So the next thing I'm going to do, I'm gonna use Web3 and ETH. So here there is a function that allows me to get the memory space and explore that. So I use this function, get a storage at. So the first parameter is the address. So I have the address. And parameter is the slot of memory or index of memory. So I would say, okay, I have no clue about the contract. So I start with slot 0. And the third argument here is basically callback function. I would say console log. And let's execute that. So I got something in hexadecimal 7B, and I'm gonna explore a little bit more to see what can I get. I get this one, and I go here. So I got something. I guess if you're familiar with ASCII code and hexadecimal, so you know that 41 in hexadecimal represents 65 in ASCII table, and it means A. And so let's make our job easier. I copy that. I use some, hex converter tools to convert that to ASCII. I just tried that on this website. I add this one. I remove this here. Convert this, so probably something is wrong. So something is wrong here. I just try to do this, and there we go. We got that. AAA BBB CCC is the key or the password here. So because this contract, has been already basically deployed in the past, so the values are not the same as I show you in this example here. But hopefully you get the point, and I hope you enjoy and find this video informative. Thank you, and see you in the next video. Bye bye.